If you live anywhere near the Mediterranean, this is the kind of update you do not scroll past. Subscribe now, because the next few minutes will explain why the ground under that whole region is starting to talk louder. Tonight, we're not doing movie panic. We're doing the kind of calm, serious breakdown that makes you sit up straight because the facts are already intense enough. Mount Etna did what Etna always does best. It reminded everyone that Europe's most active volcano does not need permission to wake up. Late December, the summit area went from quiet to explosive, with lava fountains and ash clouds that made the sky look like it had bruises in it. Italy's National Institute of Geophysics and Volcanology, the INGV team that watches Etna in real time, raised alert levels and started pushing out updates, because when Etna throws ash, aviation and nearby towns feel it fast. And this time, it was not a tiny puff. This was sustained, obvious, and strong. Now here's the part people miss. Etna is not the whole story. Etna is the loudest speaker on a much bigger sound system, because Etna sits on the edge of a complicated tectonic mess where the African plate is pushing under the Eurasian plate. That slow grind is not just a map fact. It is a pressure machine. And when pressure changes down deep, different volcanoes can show stress in different ways. So while Etna is throwing fire, other places are breathing without flames. And the place that makes scientists choose their words carefully is Campi Flegrei. That is the caldera west of Naples. A wide volcanic field, not a perfect cone, more like a huge scar in the ground that has erupted in the past in ways that rewrote local history. It is also famous for Bradyseism, which is a simple word for a creepy thing. The ground rises, then falls, then rises again, like the earth is slowly taking a heavy breath. People living there do not need a documentary to feel it. They feel it when doors stick. They feel it when cracks appear. They feel it when small quakes rattle dishes and wake babies. And that's why the phrase supervolcano keeps getting attached to Campi Flegrei. Not because someone is trying to scare you for clicks, but because its past eruptions were enormous, and the system is still alive. Now, I'm going to be blunt. Most viral volcano videos get one thing wrong. They talk like volcanoes work on a schedule. They don't. Volcanoes are messy. They are chemistry, heat, rock strength, trapped gas, and water, all arguing underground. Sometimes the argument turns into an eruption. Sometimes it turns into months or years of shaking and swelling and nothing else. So when you hear activity is increasing, that does not automatically mean eruption tomorrow. It means the system is changing enough that scientists are paying closer attention. And right now, across southern Italy and the surrounding seas, a lot of systems are changing at the same time. Let's build the map in your head, the street version, not the textbook version. You've got Sicily with Etna, a volcano that erupts often and loudly. You've got the Aeolian Islands with Stromboli, famous for its near-constant fireworks, and Volcano nearby, which even gave us the word volcano. You've got Vesuvius, the name that still makes people think of Pompeii, sitting near a huge population. You've got Campi Flegrei, a wide caldera system that keeps swelling and shaking. And then you've got something most people never think about because it is hiding underwater, Marsili. Marsili is a large underwater volcano in the Tyrrhenian Sea. Scientists have studied it for years because underwater volcanoes can have two kinds of danger. One is eruption, the other is collapse. A big collapse can push water hard enough to create tsunami risk for coastlines. Researchers have published studies on the tsunami potential from flank failures at Marsili, basically asking the scary question, what happens if part of that structure gives way? Now, I need you to hear this clearly. The existence of a risk study is not proof that disaster is guaranteed. Scientists study worst cases because that is their job. You do not wait for the house to catch fire before you buy a smoke alarm. So the picture here is not Italy's doomed. The picture is this region is one of the most geologically active neighborhoods on Earth, and it is showing more signs of motion. Now let's talk about what you asked me to do. The news report style investigation. When a major eruption kicks off at Etna, people immediately jump to the big scary question. is this connected to the rest of the region? Here's the honest answer. Sometimes volcanoes can be connected deep down through shared stress changes, but they are not like a row of dominoes where one knocks over the next on a predictable schedule. The Earth is not a clean machine. It is a living mess of forces. However, Etna's activity can still matter as a signal because it tells us the region is releasing energy. And while Etna is doing its thing on the surface, Campi Flegrei has been doing its own thing underground, with earthquake swarms, ground uplift, and persistent unrest that scientists track closely. And we do not have to guess blindly, because this is one of the most monitored places on the planet. The INGV teams use ground sensors to track seismic tremor. They use GPS stations to measure tiny ground movements. They use gas measurements to watch what is coming out of vents and fumaroles. They use thermal cameras. They also use satellite data. And this is where the story starts to feel like science fiction, except it is real. From space, we can measure Earth's surface moving by centimeters. This technique is called INSAR, Interferometric Synthetic Aperture Radar. And you don't need to memorize the name, just remember what it does. It lets scientists detect subtle ground deformation that your eyes will never catch. European Space Agency, Copernicus Sentinel satellites are famous for this kind of radar monitoring. NASA Jet Propulsion Laboratory also processes and supports radar deformation mapping products used by researchers around the world. It is one of those moments where space science meets Earth safety in a very direct way. And when you combine satellite deformation maps with local quake data, you get something that feels like an X-ray of a volcano. Not a perfect picture, but a better picture than humans have ever had before. Now, here's where the real problem shows up. Even with all this monitoring, predicting the exact timing of an eruption is still extremely hard because the system can build pressure, release it in small quakes, and then settle. Or it can build pressure quietly and then erupt. Or it can do a mix of both. So the challenge is not, can we see the unrest? The challenge is, can we read the unrest correctly? And this is exactly why artificial intelligence keeps coming into the conversation, not as a magic fortune teller, but as a tool that can find patterns humans miss in massive data streams. In fact, researchers have been using AI to detect many more small earthquakes than traditional methods catch, especially in places like Campi Flegrei, where the ground is noisy and the quake signals can be subtle. That matters because the more tiny events you detect, the better you understand how stress is moving underground. But here's the thing, AI does not replace geology, it supports it. An AI model can highlight clusters. It can flag changes. It can say, hey, this looks different. Then real scientists check it. They compare it with known physics, they look for other explanations, they test it against reality. So when you hear AI detected something, the correct reaction is not, it's confirmed. The correct reaction is it's a lead. Now, we zoom back to Etna for a second, because it is the obvious headline. What does Etna's current behavior actually mean for people nearby? Etna's biggest frequent hazards are lava flows, ash, and local explosions that can throw hot rock fragments. Lava is dangerous, but it usually moves slowly enough that you can manage evacuations and closures when needed. Ash is different. Ash can spread wide depending on wind, and ash is a nightmare for aircraft engines and visibility. It also irritates lungs and can collapse roofs if it falls heavy and wet. That's why you'll see airport warnings and flight delays around major ash events. It's not drama, it's safety. Now, Campi Flegrei is a different beast. A caldera system can produce everything from small local events to extremely large explosive eruptions in its history. The danger there is not just lava. It is also pyroclastic flows, ash, fall, and the chaos of evacuating a dense population if the system ever escalates toward eruption. And that's where the fear gets real, because the hardest disasters are not always the biggest blasts. The hardest disasters are the ones that force millions of people to move. So if you're asking, why do scientists speak carefully about Campi Flegrei? That's your answer. Not because they want to scare you, because they understand the stakes. Now, let's address the solar cycle point in your summary, but we're going to do it responsibly. The sun does go through cycles of activity. During stronger solar periods, we see more solar flares, more geomagnetic storms, more energy dumping into Earth's upper atmosphere. NASA missions like the Solar Dynamics Observatory and Parker Solar Probe, along with NOAA's Space Weather Prediction Center, track this constantly. But the idea that solar activity directly drives eruptions is not a settled fact. Some researchers explore links between solar, geomagnetic, and Earth system variability. But volcanoes are primarily driven by heat and pressure inside Earth. If solar effects matter at all, they are subtle and indirect, not a simple on-off switch. So here's the safe, honest way to say it. Space weather can affect Earth's magnetic environment and the upper atmosphere strongly. It can affect power grids, satellites, radio communication, and navigation. But when it comes to volcanoes, the core drivers are still deep Earth processes. If you ever see someone claiming a single solar flare caused a volcano to erupt, that person is overselling it. Now, that does not mean we ignore the sun in this story, because even if the sun is not the cause, it is still part of the larger danger picture. Imagine a scenario where a major volcanic ash event disrupts aviation and communications, while a geomagnetic storm is also stressing satellites and radio signals. That is not fantasy. That is two real systems overlapping. And that's why this kind of content belongs in a channel that covers both Earth science and space systems. Because modern life depends on both the ground and the sky. Now, let's widen the frame again and talk about why now feels louder. One reason is simply that we have better sensors, more cameras, more seismic stations, more satellites, more people filming everything. So the world can feel like it is shaking more because we are measuring more. But another reason is that some regions really are experiencing active phases. Campi Flegrei has been in an unrest phase for years. Studies have looked at the relationship between uplift and earthquake patterns there, treating the system like something that can cascade and cluster rather than behave in a neat straight line. Etna has had multiple energetic episodes in a single year. That alone doesn't mean a bigger event is guaranteed, but it tells you the magma plumbing is active. And if you connect those facts with the existence of large volcanic systems under the sea, like Marsilli, it becomes reasonable to say the Mediterranean is a high attention zone, not a panic zone, a high attention zone. Now, here is the open loop I promised at the start, the one that keeps people watching. If Etna is the loudspeaker we can see, and Campi Flegrei is the quiet giant we can feel, then what is happening in the parts we cannot see at all, under the sea, under sediment, under layers of rock? And more importantly, what would a real escalation actually look like in the data before the public ever sees flames? Because if you want to be early, you don't wait for lava. You watch the signals. So let's do the part most videos skip, because it's not flashy, but it's the difference between real warning and internet noise. When scientists say a volcano is waking up, they're not staring at lava. They're staring at a handful of signals that tend to change before the show starts. Think of a volcano like a sealed soda bottle that's been shaken. You can't see the pressure, but you can see the cap flex. You can hear the fizz. You can feel the bottle get warmer. You can notice tiny leaks. Volcano signals are basically the Earth's version of that. The first signal is earthquakes, but not just any earthquake. They look at where the quakes are, how deep they are, and whether they're moving. Because a lot of shallow quakes in the same place can mean rocks are cracking as fluids push through. But deep quakes creeping upward over time can be a different kind of story. At Campi Flegrei, for example, the big headline isn't a single monster quake. It's the pattern. Swarms, clusters, repeated shaking, and the fact that people there have felt unrest for years. And when researchers dig into the data with better tools and newer methods, they often find there were more small quakes than older systems even counted. Not because the ground suddenly got worse, but because we got better at hearing it. Now, the second signal is the one that creeps people out the most because it's so physical. Ground, uplift. You wake up one day and the street is slightly different. The porch sits higher. The floor feels off. Doors don't shut the same way. Cracks show up in walls that were fine last year. That's Bradyseism. Slow rise, slow fall. And it matters because when the ground rises, something is pushing from below. It could be magma. It could be hot gas. It could be hot water and steam building, pressure in the rocks. Sometimes it's a mix, and that's why scientists argue carefully about what the uplift means. Here's what makes it scary. You can have serious uplift without an eruption. And you can have an eruption with less warning than people expect. So uplift is not a countdown timer. It's a stress gauge. Now, how do we even measure uplift well enough to trust it? Two ways. One is on the ground, with GPS stations that can detect tiny movements. The other is from space, using radar satellites that can see the Earth's surface shift by centimeters. That's the INSAR stuff we mentioned earlier. It's one of the most powerful tools we have because it doesn't care if it's cloudy, and it can cover big areas again and again. That's why radar missions like Europe's Sentinel satellites became such a big deal for volcano monitoring, and why NASA teams like the Jet Propulsion Laboratory, working with Caltech and partners, help turn radar data into maps scientists can actually use quickly when things change. Now, the third signal is the one people don't talk about enough, because you can't see it with your eyes. Gas. Volcanoes leak gas even when they're quiet, but the type of gas, the amount, and how it changes can tell you what's happening down deep. A lot of volcano systems release carbon dioxide first because it escapes more easily from depth. Sulfur dioxide can rise when magma gets closer to the surface. And changes in gas can also show shifts in the underground plumbing even without magma moving. At places like Campi Flegrei, you also have fumaroles, vents where steam and gas escape. When those gases get hotter, where the chemistry shifts, it's another piece of the puzzle. So when scientists take gas measurements, they're not sniffing for doom. They're tracking the underground system like a doctor reading vital signs. Now, the fourth signal is heat. Thermal changes can show up at vents, crater walls, or even through satellite thermal imaging. If a zone that used to be cool becomes consistently warmer, that can mean hot fluid is moving or new pathways are opening. Mount Etna is perfect for explaining this because it can switch modes fast. It can go from quiet to loud, and the monitoring network catches the buildup. Increased tremor, changes in deformation, changes in heat, and then the surface finally gives you the fireworks everyone sees. And when Etna's northeast crater wakes after decades of being quiet, that's not just a fun fact. That's the volcano reminding you that dormant does not mean dead. It can mean waiting. Now, here's the fifth signal. And this one is the sneakiest. Volcanic tremor. Not a normal earthquake, not a single crack, but a continuous vibration, like a low engine hum in the rock. Tremor often increases when magma or hot fluids move because the system is basically shaking from the inside. This doesn't always mean eruption is next, but it's one of the signals that makes scientists lean forward in their chairs. So those are the 5 big ones: quakes, uplift, gas, heat, tremor, and here's the uncomfortable part. A supervolcano system like Campi Flegrei can show some of these signals for a long time without erupting. That can be frustrating for people because they want a clear yes or no. But nature doesn't owe us a clean answer. It gives us probabilities. It gives us trends. It gives us risk. And it gives us one job: pay attention without panicking. Now let's talk about the underwater side, because this is where the Mediterranean gets even more serious. When something is underwater, it's harder to watch. You don't have a crater you can point at on a webcam. You have to use bathymetry mapping, seismic networks, and marine surveys. You look for signs of instability on the slopes. You study old scars where collapses happened before. You model what a collapse would do to the water above it. Marsilli is often mentioned here because it's huge, and because researchers have specifically studied what happens if parts of submarine volcano flanks fail. The scary word is tsunami, but the smart approach is study it early, improve monitoring, and don't let the first time you take it seriously be after something moves. That's the theme of this whole story, by the way. Early, not late. Now, there's another layer to this story that people love to fight about online. The idea that all of this is connected. Etna, Campi Flegrei, Stromboli, the underwater systems, earthquakes, and even the Sunday. Here's the clean truth. The Mediterranean region sits on a complicated tectonic boundary. So yes, there are deep forces shaping everything, but that doesn't mean every eruption triggers the next one like a chain reaction. It means the whole region is a high-energy zone with multiple systems that can show unrest in overlapping time periods. Some are driven mostly by magma supply, some by hydrothermal pressure, some by stress changes in the crust. And the reason scientists don't make wild claims is because the data can fool you. Nature makes patterns, and humans love turning patterns into certainty. That's why I'm going to say something that might sound boring, but it's the most important line in the whole video. If a claim is huge, the proof has to be boring. So if you're hearing dramatic claims like the Mediterranean is about to blow, the correct response is, show me the boring proof. Show me the consistent trends across multiple instruments. Show me deformation that's accelerating in a way that matches known eruption buildups. Show me gas chemistry shifting in a direction that supports magma moving upward. Show me tremor increasing in a way that matches past pre-eruptive patterns. Show me the boring stuff, because that's how science protects people. Now, where does AI fit into this in a way that makes sense? AI is not the oracle. AI is the intern with unlimited energy. It can scan giant data sets and say, hey, look here. It can detect tiny quakes hidden in noise. It can help map fault structures that explain why swarms cluster where they do. It can spot subtle changes in patterns that humans might overlook, but it still needs humans to judge what it means. So when someone says, AI says the supervolcano is waking up, the honest translation is usually, AI found a pattern that scientists now need to test. And that's not scary, that's responsible. Now, we're going to connect this back to the title, because you're not here for a lecture. You're here because the Mediterranean is starting to feel louder. The core fear isn't Etna's lava. Etna's loud, but familiar. The fear is the idea of multiple systems showing unrest in the same region around dense populations, with the added complication of underwater hazards and non-stop misinformation online. So here's the question that matters most for real people. What would escalation actually look like before the headlines? And the answer is usually a combination of three things. A clear increase in earthquake energy or frequency in the same critical zone, a measurable acceleration in uplift, and geochemical changes that support deeper pressure moving upward, not just surface level steam noise. That's the kind of pattern that makes scientists shift from watching to preparing. And this is where the story becomes personal. Because if you live near these areas, the worst thing you can do is either panic or ignore it. Panic makes you spread rumors and waste time. Ignoring it makes you unprepared. The correct middle ground is awareness. Know what official monitoring agencies say. Understand the basic signals. And know that the goal of science isn't to scare you. The goal is to give you time, because this is where most people mess up. They hear volcanic risk, and their brain turns it into one of two extremes. Either, we're all fine, they say this every year, or, we're finished, pack your life into a backpack. Both reactions are understandable. Both are wrong. The reason is simple. People confuse three different things like they're the same. Hazard, risk, and warning. Hazard is what the volcano can do in general. Ash, lava, gas, big blasts, small blasts, ground shaking. Risk is hazard plus people. If nobody lives nearby, the same hazard can be a small problem. If millions live nearby, the same hazard becomes a huge problem. And warning is what we can actually say right now based on data. Warning is not fear. It's a measured statement like, we are seeing more uplift, or we are seeing more swarms, or gas chemistry is changing. So when someone tells you Campi Flegrei is dangerous, that can be true as a hazard statement. But when someone tells you Campi Flegrei will erupt this week, that's a warning claim. That requires hard evidence. And most of the time, they don't have it. And here's the part that will keep your audience locked in, because it's the real villain in these stories. Uncertainty. People hate uncertainty. They want a countdown clock. They want a single expert to point and say Tuesday. But geology doesn't speak that language. It speaks in chances, trends, and ranges. So what happens online is predictable. Someone takes a real cautious statement like unrest is increasing, and they translate it into eruption confirmed. Then someone else gets angry and says, this is all fake. And the public gets whiplash. Meanwhile, the ground keeps doing what it's doing. So the smartest move for viewers is not to hunt for the scariest headline. It's to learn what escalation actually looks like in real monitoring. Let me paint a clear picture. Escalation is not just more quakes. It's more quakes at meaningful depths, in meaningful places, moving in meaningful ways. Escalation is not just uplift. It's uplift that accelerates and lines up with other signals. Escalation is not just steam looks stronger. It's changes in gas chemistry that suggest the source is getting hotter or deeper pressure is rising. Escalation is when multiple instruments agree, because any one instrument can fool you. Seismic sensors can pick up noise. Gas can shift due to weather. Heat can shift due to surface changes. But when the same story shows up across several tools, that's when professionals pay attention. And here's the part that helps your viewers feel grounded instead of helpless. There are official groups whose entire job is to watch these signals. In Italy, INGV is a big one. Globally, agencies like the USGS also publish clear explainers on how volcano monitoring works, what alerts mean, and what the public should do. And from space, there are eyes that never blink. The European Space Agency's Copernicus satellites, NASA Earth Science missions, NASA and JPL teams that work on radar and deformation mapping products that researchers use to understand ground movement. That's why this story actually fits a channel that covers space, because some of the most important volcano information comes from orbit. Now, let's deal with something else your viewers will ask in the comments. If we can watch volcanoes this closely, why can't we just stop a disaster? Because the goal is not to stop the Earth. The goal is to buy time. Time to reroute flights when ash is coming. Time to close roads when lava is advancing. Time to warn people to stay indoors when gas conditions are bad. Time to prepare evacuation routes if there's a credible escalation. Time is the real weapon. And that's why early monitoring matters even if nobody can name a day. Now, since you're doing news report style, you want a clean, relatable section that makes the viewer feel like you're standing beside them, not above them. So let's make it real. If you live near Etna, what changes your day-to-day is usually ash, roads, and air quality. If you live near Naples, what changes your day-to-day is shaking, and ground changes, and constant rumors. If you live near the coast, underwater hazards become part of the risk conversation, even if they're rare. Different hazards, same region, same underlying truth. This is one of the busiest geologic zones on the planet. Now, I want to bring in one more key point that most people don't know. A lot of the time, the most dangerous part of a volcanic crisis is not the eruption itself. It's the confusion before it. If people don't trust official sources, they trust random accounts. If they trust random accounts, they either panic too early or ignore warnings too late. So the best preparation is not just supplies. It's clarity. It's knowing where to look when something changes. Because when the ground starts shaking and the rumors start flying, you don't want to be searching for who do I believe in the middle of the storm. You want that decided in advance. Now, let's talk about what smart preparation looks like without turning this into a survival channel. First, don't overreact. Second, don't be asleep. If you live in a volcanic region, the smartest thing you can do is a basic plan that costs almost nothing. Know your local hazard types. Ash is different from lava. Lava is different from gas. Gas is different from quakes. Have a simple family plan for communication. Know which roads are the main exits and which ones choke fast. If you have breathing issues, a good mask is not dramatic. It's common sense during ash or poor air quality days. If you're coastal and there's ever talk of tsunami risk, know the higher ground routes. Not because you're expecting it tomorrow, but because you don't want to be learning geography in a panic. And the easiest one of all, don't wait for rumors. If a volcano region is active, Official monitoring updates are more useful than any dramatic video with spooky music. Now, let's connect this to your title again, because your title is about increased activity around a lurking supervolcano. That word lurking is powerful, but it can also trick people into thinking the volcano is hiding, like it's sneaky on purpose. The reality is even more unsettling. It's not hiding. It's right there. We just can't see the machinery because it's underground. So the question becomes, how do you see a hidden system? You see it through patterns. You see it through swarms. You see it through uplift. You see it through gas. You see it through heat. You see it through satellite deformation maps. And that brings us to the most relatable part of the whole story, the thing people will remember. The Earth leaves clues before it changes the rules. Not perfect clues, not always early enough, but clues. Now, one more thing we have to address, because it always shows up. Conspiracy talk. The moment anything shakes in Italy, someone will say, they're hiding something. Here's the reality. Volcano monitoring is one of the most public, data-heavy sciences on Earth. There are live seismograph feeds, there are scientific bulletins, there are satellite products, there are university researchers who publish papers. There are international teams that compare data. If someone claims they're hiding the eruption, ask them to explain how they're hiding ground uplift that satellites can measure. Ask them how they're hiding earthquakes that are felt by thousands of people. Ask them how they're hiding ash clouds that disrupt air traffic. The simplest answer is usually the true one. Nobody is hiding the volcano. The volcano is just complicated. Now, I want to shift the mood slightly because long videos need breath. Let's do a quick mental picture. Imagine Earth as a planet with two tempers. One is quick. That's weather. Storms can form in hours. Winds can flip overnight. The other is slow. That's geology. It can build pressure for years, decades, centuries, and then change a whole region in one day. That's why it feels eerie, because the slow system moves silently until it doesn't. Now, there's one last open loop we need to set up before the story hits its most intense stretch later. If we accept that Etna is active and Campi Flegrei is restless, and the Mediterranean has major systems both on land and underwater, then the real question is not, is something going to happen? The real question is, if something starts to escalate fast, what are the first signals that would separate normal unrest from a genuine shift toward danger? Because that's the line between interesting science and public action. And the next part is where we get very specific. We're going to walk through what scientists watch for when a system moves from background unrest into a higher alert mode, what higher alert actually means in real life, and why the most important goal is not fear. It's time. Time to think clearly, time to move wisely, time to keep people safe without turning the whole region into chaos. All right, now we get into the part that separates real monitoring from vibes. Because a volcanic system doesn't jump from calm to catastrophe like a jump scare. Most of the time, it climbs a ladder. And the steps on that ladder are what scientists and emergency planners care about. Here's what that ladder looks like in plain street language. Step 1 is background noise. Small quakes, a little tremor, some gas, some heat. Nothing that screams, just a system being alive. Step 2 is persistent change. Not one weird day, a trend, a week, a month, a pattern that keeps repeating in the same zones. Step 3 is acceleration. This is where people should stop arguing online and start listening to official updates, because accelerating is the word that turns curiosity into attention. Acceleration can look like quake swarms getting more frequent, or the ground rising faster than before, or gas output getting hotter and richer in the kinds of gases that hint at deeper pressure. Step 4 is coupling. That's when multiple signals start telling the same story at the same time. Seismic changes line up with deformation changes. Gas changes line up with heat changes. That agreement is what gives scientists more confidence. And step 5 is the ugly one. Rapid change. Big swarms that don't calm down. Strong tremor that stays elevated. Ground shifts that speed up. That's the stage where civil protection, starts thinking in terms of readiness, not theory. Now, notice what I didn't say. I didn't say one big earthquake means eruption, because that's a common misunderstanding. A big earthquake can happen near a volcano and not lead to eruption. A lot of volcano quakes are small but meaningful because of where they happen and how they cluster. So the real question isn't, was there an earthquake? It's, what did the system do next? Did it calm down? Did it keep clustering? Did the quakes migrate? Did the tremor rise? Did the ground continue to lift? Did gas readings shift? That what happened next is where the truth lives. Now, let's talk about how officials actually make decisions. Because people imagine there's one dramatic button that says evacuate. In reality, it's a slow, stressful process of balancing two dangers. Danger one is moving too late. Danger two is moving too early. Moving too late costs lives. Moving too early can also cost lives in a different way, by creating chaos, crashes, panic, and breakdown of trust. It can also destroy livelihoods, because people can't just pause a city for weeks. So agencies like Italy's Civil Protection work with monitoring groups like INGV to make choices that are as measured as possible. And that's why official statements can sound cautious. They're not hiding. They're trying not to trigger a stampede. Now, here's where you give viewers something solid and relatable. If you want to know whether an increase is meaningful, ask yourself 3 simple questions. Is it sustained? Is it accelerating? Is it confirmed by more than one tool? That's it. Because a one-day spike can be weather noise. A single sensor can glitch. A single viral clip can be fake. But sustained acceleration across multiple tools is hard to fake. It's also hard to ignore. Now, I'm going to bring in the space angle again, because it matters here in a way most people don't realize. When you hear volcano monitoring, you imagine people standing near a crater with a mask and a clipboard. Yes, that exists, but some of the most important data comes from satellites. Copernicus Sentinel radar can map ground deformation. NASA and partner missions can track heat signatures. You'll hear scientists mention instruments like ASTER, VIRS, Landsat, and MODIS in volcanic monitoring discussions, because these sensors can detect hot areas, ash movement, and changes over time. And when researchers combine that with ground networks, it becomes like having a second set of eyes that watches the whole region at once. So if you're wondering why a NASA-style channel is talking about Mediterranean volcanoes, that's your reason. Modern volcano monitoring is partly space science. Now, there's another part of the story that people don't expect, and it's one of the scariest pieces because it's quiet. Gas and air. Not lava, not ash clouds that look dramatic on camera, just invisible air that can hurt people. Volcano areas can release carbon dioxide and other gases that pool in low spots, especially in calm weather. In rare situations, gas can become the first serious hazard even without a big eruption. That's why stay out of restricted zones is not boring advice, it's survival level advice. At places like Campi Flegrei, there are fumarole fields where gas and steam are part of daily reality. The reason scientists measure gas there is because gas can reveal changes long before any lava shows up. Now, I want to pull you into a mental scene that makes all of this click without you needing a geology degree. Imagine you're standing in a room with a huge speaker hidden behind a wall. You can't see the speaker, but you can hear vibrations. You can feel the wall warm slightly. You can hear a low hum. You can feel little rattles in the floor. Sometimes it gets louder, then quiet again. That's Campi Flegrei. That's why it creates anxiety. Because humans fear the unseen machine more than the visible fire. Etna is visible fire. People can point at it and say, that's the crater. Campi Flegrei is an entire area that can act like one system, and you feel it more than you see it. Now, here's where things get even more interesting, and I'm going to say it carefully. Volcanic unrest is not rare. What is rare is when unrest crosses a line into a clearly escalating phase. So the big story is not there are earthquakes. The big story is how are the earthquakes changing? Not the ground is rising. But is the ground rising faster than before? Not gas is coming out, but is the gas hotter, stronger, and changing chemistry? Those are the questions that turn background noise into warning. And here's the tension that makes this video work for a long watch. Some of the scariest volcanic systems on Earth are capable of very large events, but their day-to-day behavior can look similar to systems that never do anything dramatic in our lifetime. So the only way to stay honest is to tell viewers two truths at the same time. Truth one, Campi Flegrei is a powerful system with a serious history, and it sits near a huge population. It deserves respect and monitoring. Truth two, unrest does not automatically mean eruption soon. Most unrest periods do not end in a major eruption. Both truths are real. The hard part is living in between them. Now, let's talk about the Mediterranean arc as a whole, because your title is about increasing activity surrounding a lurking system. This region isn't one volcano. It's a neighborhood of systems. Etna can erupt while Campi Flegrei swells. Stromboli can throw steady bursts while Vesuvius stays quiet. Submarine systems can shift without anyone seeing a surface sign. And earthquakes can happen in the same broad region because tectonic plates are still grinding. So when someone asks, are they connected? The best answer is, they are connected by the same deep tectonic setting. But each system still has its own personality, its own plumbing, its own timing. That answer may not be dramatic enough for a comment section, but it's the one that keeps people safe. Now, let's address a big myth that causes a lot of panic. The myth is that if a supervolcano erupts, it happens instantly with no warning. Reality is more complicated. Large systems often show long periods of unrest, with many false starts and pauses. That doesn't mean we can predict everything, but it does mean there are usually signals. The problem is not that signals don't exist. The problem is reading them correctly and deciding what action matches the risk. That's why monitoring exists. That's why scientists publish updates. That's why civil protection makes readiness plans. Now, here's the part where your audience will lean forward, because you're going to answer the question they actually care about. If the Mediterranean really is heating up, what should people watch for next? Not rumors, not dramatic edits, actual meaningful signs. 1. An unusual increase in earthquake swarms in the same exact area, especially if the quakes get shallower or migrate. 2. Uplift that accelerates and stays elevated, not a tiny bump that returns to normal. 3. Gas measurements shifting consistently, especially if temperature and output increase. 4. Tremor rising and staying high, especially if it matches patterns seen before eruptions in that specific volcano. 5. Visible surface changes in known vents or fumarole fields, like new cracks, stronger steam jets, new hotspots, or sudden changes in water chemistry in nearby areas. And 6, the big one, multiple independent groups seeing the same trend. That's why it matters when INGV bulletins, satellite deformation maps, and field measurements line up. Now, I'm going to tie this to the solar cycle point again, but only in a way that's honest. Space weather is real. NASA and NOAA track it. Satellites can be affected. Power systems can be affected. Radio can be affected. So if you ever get a period where volcanic ash is in the air and geomagnetic storms are also stressing communication and satellites, that overlap can make a crisis harder to manage. That doesn't mean the sun caused the eruption. It means the world is a system of systems, and sometimes problems overlap. That's the kind of realistic fear that doesn't need exaggeration. Now let's do something important for watch time. Let's bring the viewer emotionally back to ground level. If you live near these volcanoes, the worst part of an unrest period is not the science. It's the waiting. It's the, is this just another swarm? Or is this different? It's the way rumors spread faster than facts. It's the stress of hearing a new tremor at night. So this video is not here to scare people into panic. It's here to replace panic with understanding, because understanding makes better choices, and better choices save lives. Now, we're coming up to the most intense part of the story, and I'm not going to jump there yet, but I will set the next open loop. There is one specific reason why the Mediterranean region can produce cascading impacts even from medium events. It's not just the volcano. It's the human density, the transportation network, the air traffic, the ports, and the way ash and fear move across borders. Good. Now we're going to do the realistic chain reaction piece, because this is where a volcano in Italy stops being just Italy's problem. Not because the whole world ends. Because modern life is built on networks, and volcanoes love to stress networks. So let's build a calm, believable scenario. No screaming, just truth. Imagine Etna stays active for days, with repeated lava fountains and intermittent ash bursts. Nothing unheard of for Etna, but strong enough that ash keeps getting into the air. The first impact isn't lava, it's the sky. Airports start adjusting, flights reroute, some cancel. Delays stack up. People get stuck in terminals. Cargo gets pushed back. Crews hit schedule limits. This isn't dramatic. It's just how aviation works when ash becomes a risk. And that's the first important lesson. A volcano doesn't need to destroy a city to disrupt a region. Now, shift north toward Naples. Campi Flegrei doesn't erupt in this scenario yet, but it stays restless. Swarms keep happening. The ground keeps doing slow uplift. People feel small shakes often enough that it becomes the background soundtrack of daily life. Here's what happens next. The public attention begins to drift from the science to the emotion. You see a lot of videos. Some are real, some are old clips, some are edited, some have captions claiming eruption confirmed. And then two things happen at once. Some people start to panic early. Other people start to mock everything. That split is dangerous because it breaks trust. And when trust breaks, even good warnings get ignored. So the real threat is not only the volcano. The real threat is the information environment around the volcano. Now, here's how emergency planning actually thinks. They don't plan for one event. They plan for what events do to systems. If ash persists, you have reduced visibility and air quality issues, road cleanup and closures, strain on hospitals for respiratory cases, especially older people and kids, power and water systems dealing with ash infiltration and maintenance. If earthquakes persist in a dense area, you have people sleeping less, stress rising, schools dealing with safety concerns, businesses losing confidence and losing money, tiny building damages accumulating, which increases anxiety. Now add one more layer, tourism. The Mediterranean region lives on movement. People fly in, ferry out, drive through. If the headlines get scary, tourism drops fast, even if there's no major eruption. That impacts jobs, and when jobs are stressed, communities get stressed. So again, the volcano doesn't need to blow up for the human impacts to grow. That's why the word unrest matters. Unrest is not nothing, it's a condition. Now, let's talk about the underwater side in a way that keeps the viewer grounded. Submarine volcanoes like Marsilli aren't on people's minds day to day, because you can't watch a crater glowing on a webcam. But underwater systems matter for one reason. You can't eyeball them. So scientists use seafloor mapping, seismic monitoring, and modeling to understand stability. The scary scenario people fear is a sudden flank collapse that pushes water, creating tsunami risk. But here's the honest part. The probability of that happening soon is not something a YouTube channel can declare with confidence. That's the kind of claim that needs hard data. So how do you cover it responsibly? You say, it exists, it's being studied, and it's one reason monitoring matters. Not, it's definitely happening. Because the goal is credibility. Fear without credibility dies fast. Credibility keeps people watching. Now, we bring in the space angle again because it fits naturally here. If you want to monitor the Mediterranean region as a whole, you need eyes that see beyond one crater. And that's where satellites shine. Radar deformation maps show uplift patterns. Thermal imaging flags, hot zones. Atmospheric monitoring tracks ash and sulfur dioxide plumes as they drift. And this is where you can mention real agencies and missions in a natural way without breaking flow. NASA Earth Science satellites, ESA Copernicus missions, and the teams at NASA JPL who work on turning raw data into usable maps for researchers. This is the modern reality. Some of the best volcano monitoring happens from orbit. Now here's the uncomfortable truth that makes people lean in. Even with all of that, the hardest part isn't the science. The hardest part is decision timing. Because if Campi Flegrei ever escalates toward eruption, It won't be one village moving out. It could involve huge evacuation decisions around Naples. And that is one of the hardest things any government can do. Because if you evacuate and nothing happens, people get angry. But if you don't evacuate and something happens, people get hurt. So emergency planners have to live in a world where every decision has a cost. And that's why you see cautious language in official updates. Now let's do a little myth busting that is actually worth watch time. People think supervolcano means instant global winter. Reality is more nuanced. A very large eruption can absolutely have global climate effects, depending on how much sulfur dioxide reaches the stratosphere. But not every eruption from a supervolcano system is supersized. A caldera system can produce a range of eruptions: small, moderate, large, very large. So when someone uses the word supervolcano as if it guarantees the biggest possible event, they're oversimplifying. But here's the part that keeps the fear alive without lying. Even a moderate eruption in the wrong place can be a massive human crisis because of ash, infrastructure, and population. So you don't need to sell world ending. You only need to show how region changing is already a serious problem. Now, I'm gonna pull the viewer back again with a simple image. Think of the Mediterranean as a crowded room with multiple candles. Most candles flicker harmlessly, but if one candle tips and the curtains are close, suddenly the room is a problem. Population is the curtain. Infrastructure is the curtain. Air travel is the curtain. And volcano ash is the spark that spreads. Now, let's talk about the biggest misunderstanding people have about prediction, because it matters for trust. People think prediction is a yes/no statement. Scientists think prediction is a probability statement. So if scientists say unrest is increasing, the internet hears eruption confirmed. And then when eruption doesn't happen quickly, people say, see, they were lying. But increasing unrest never meant eruption tomorrow. It meant the system is changing and needs attention. This is why good communication matters. And this is why your video should feel like a calm investigator, not a scared influencer. Now, we need to tighten the open loop again. Because we've covered how unrest can affect real life, but we haven't answered the question that's sitting in the viewer's mind like a stone. If this really escalates, what is the point where officials would change the alert level? What is the point where they stop saying monitoring and start saying prepare? And now, all. And what would the public see first? The public doesn't see gas graphs. They don't see tremor plots. They see shaking. They see steam. They see cracks. They see ash. They see closures. Because if you're a normal person living near a restless volcanic area, you're not reading seismograph charts on your phone at 2 a.m. You're asking one simple question. Is this still the usual noise, or is this different? So here's what different tends to look like. Without drama, without guessing. First, shaking that changes character, not just one shake, not just a random bump, but repeated shaking that feels clustered, like the ground is tapping you on the shoulder again and again. People start noticing a rhythm to it. Not a perfect rhythm, but a pattern. They start saying things like, it's happening every night, or it's happening in waves. Second, more reports of small damage, not buildings falling down, but little things. New cracks, old cracks opening wider, tiles shifting, doors sticking, a few minor collapses in weak structures. These are the kinds of things that don't look scary on camera, but they change how a community feels. It's the physical reminder that the ground is not settled. Third, changes in steam and smell in known vent areas. People who live there will tell you when a place smells different, when steam looks thicker, when heat feels stronger, when the air feels sharp in the throat. That doesn't prove an eruption is coming, but it is a sign the underground system is active and shifting. Fourth, official wording changes. This one is huge. Most people ignore it. But agencies choose words for a reason. When updates go from routine to more frequent, when they stop using calm phrases and start using firm phrases like increased attention, elevated, or escalation, when they start recommending specific actions instead of general awareness, that shift is one of the clearest signs that professionals are seeing a meaningful change. Fifth, more restrictions. You'll see closed zones. you'll see access limits, you'll see certain areas become no-go. Not because someone wants control, because gases can concentrate, because sudden small explosions can happen, and because when a system is more active, you don't let people stand on the edge just to take a selfie. Now, notice something. None of those signs require you to believe rumors. They are things you can feel, see, or confirm through official updates. That's the key. Now, the hardest part for people is this. Sometimes a system can show several of these signs and still not erupt for a long time. That's not failure. That's how geology works. It's like watching a storm build over the ocean. Sometimes it turns into a hurricane. Sometimes wind shear tears it apart. But you still take it seriously while it builds. So the correct mindset is not panic, it's readiness. Now, there's another thing that changes when unrest grows. And it's one of the most human things in this whole story. Sound. People report strange sounds during swarms, low rumbles, distant booms, vibrations that feel like a heavy truck passing when no truck is there. Sometimes those reports are real physical effects. Sometimes they're the brain reacting to stress. Often it's both at once. And when people start hearing and feeling these things, the whole community mood changes. You see it in how people talk. You see it in how they drive. You see it in how kids sleep. You see it in how shops close earlier. That's why unrest is not just science, it's psychology. Now, let's bring it back to the Mediterranean situation you're covering. Etna can be loud without forcing a massive evacuation because it's a volcano that erupts often and is monitored heavily. The risk there is serious, but the system is more familiar in how it behaves. Campi Flegrei is different because it sits under and beside dense towns and a major city area. That makes every decision heavier. So if the public ever sees changes that feel like escalation, the real danger is not just a potential eruption. The danger is the reaction. People rushing the same roads at the same time. People believing the wrong source. People ignoring the right source because they're tired of rumors. So the smartest thing you can do for viewers is give them one simple rule. When the ground is loud, listen to the sources that don't need to shout. Because the people who actually monitor these systems don't win by scaring you. They win by being right. Now, we have to talk about one more thing that makes this region feel extra tense. The Mediterranean is not one hazard at a time. It's many hazards stacked close together. Volcanoes, earthquakes, submarine systems, dense cities, busy air routes, coastlines. So even if the chance of a worst case is small, the consequences of being unprepared can be high. That's what makes it feel scarier. Not because disaster is guaranteed, because the margin for confusion is thin. Now, let's go deeper into the main fear behind your title. When people hear supervolcano, they imagine one giant blast, and then the world goes dark. But the more realistic danger, short term, is a long period of unrest that keeps rising in intensity and keeps communities trapped in uncertainty. And that's why monitoring updates matter so much, because they are the only stable voice when people start inventing stories. Now, let's do a clear and calm walkthrough of what monitoring teams look for when they start thinking about the next level of readiness. They look for signs that fluids are moving in a way that is not just surface steam. They look for changes in earthquake depth and location that suggest pressure is migrating. They look for deformation patterns that expand or accelerate. They look for gas shifts that suggest hotter sources. They look for persistent tremor that doesn't drop back down. They look for surface changes in known hot zones. And the reason they look for all of that is simple. They don't want one clue. They want a stack of clues, because one clue can lie. A stack of clues is harder to argue with. Now, here's the open loop that keeps people watching without needing scare tactics. If the Mediterranean region really is entering a more active phase, the question is not, will it erupt? The question is, how do we tell the difference between noisy unrest and meaningful escalation? And the answer is a checklist of real signs that show up across time, not a single headline. It always hits hardest at a normal hour, not during some dramatic sunset, not during a movie-style countdown. It hits when people are doing regular life and the phone buzzes. And you can tell from the first line that the tone has changed. A new bulletin drops from INGV, and it isn't the usual calm, technical recap that only the science crowd reads. It's still measured, still careful, but the words land heavier, more frequent swarms, a clear jump in tremor. Ground movement that isn't just up and down, but trending in a way that refuses to settle back. It's the kind of update that makes even skeptical people stop scrolling. And at the same time, Etna keeps doing what Etna does, throwing fire like it's bored of being ignored. Lava fountains punch upward, ash goes into the air, and within hours, the sky becomes a logistics problem. Flights reroute. People complain. Some laugh it off. But the people who manage risk don't laugh. They start adding layers of contingency. Because this is the nightmare combo for any region with dense cities and busy air routes. One system is loud and visible, another is quiet and unpredictable. And now, the signals are starting to line up close enough to make everyone feel the same thought, even if nobody says it out loud. What if this is not just noise? What if this is the start of something that forces real decisions? That's the moment the story stops being about rocks and magma and turns into a story about humans. You can feel it in the way people talk. The jokes disappear. Conversations get shorter. There's a certain kind of silence that shows up when people are trying to stay normal, but their bodies are already listening for the next shake. Then the ground does it again. Not one dramatic punch, more like repeated nudges. Enough to rattle cups, enough to set off car alarms, enough to make a kid ask a question that adults can't answer without lying. Is it gonna get worse? In the monitoring rooms, nobody is guessing. They're comparing. They're stacking signals like evidence in a case file. Seismic data says the system is more active than it was. Deformation data says the surface is moving in a consistent direction. Gas readings, where they exist, hint that the underground plumbing is not just steaming, it's pressurizing. Thermal spots show persistence, not a one-day flare. And when multiple tools agree, that's the closest thing Earth science has to a raised eyebrow. This is where the space part becomes more than a cool detail. Because while people argue online, satellites are doing what they always do, watching without emotion. Radar mapping from orbit can show subtle changes in the surface that a human standing on the ground would never notice. The same kind of space-based watching used all over the world for ground deformation, the kind of work researchers lean on when they need a broader picture than a single city can provide. And when those maps show a change that matches what ground sensors already saw, it feels like the planet is signing its name at the bottom of the page. Now the pressure shifts from science to leadership. Italy's civil protection system doesn't get to live in theories. They live in consequences. They have to think about roads, hospitals, schools, ports, airports, and the simple truth that a crowd can be more dangerous than the hazard if the crowd panics at the wrong time. So you start seeing quiet, practical moves. Not sirens, not a million people running, but meetings, briefings, restricted zones tightened, messaging adjusted, a little more seriousness in the language. And here's the key moment, the part that makes this whole story feel like a human thriller without anyone exaggerating. A senior official stands up and says, in plain words, that the region is being watched closely, and that the public should rely on official updates, not rumors. That sentence sounds boring until you realize what it really means. It means the people who see the data first are preparing for the public to react badly, because the internet always races ahead of reality. Someone posts a shaky clip of steam and claims it's an eruption starting. Someone reposts an old Etna video and says, it's happening now in Naples. Someone draws a red circle on a map and calls it a kill zone. And then the comment section does what it always does. Half the people say it's the end. Half the people say it's fake. And the most important third group, the people who just want to stay safe, are stuck in the middle trying to figure out what to believe. This is where you, as the narrator, earn trust. You say it straight. We do not need aliens. We do not need prophecies. We do not need secret projects. We need boring proof. And right now, the only thing that matters is what the instruments say, what the monitoring agencies report, and how the trends change over days and weeks, not minutes and memes. Because the Earth does not care about your timeline. It moves when it moves. Then, in the middle of all this, one more detail lands like a cold coin on the table. Even if nothing big happens tomorrow, the region has already entered a phase where the risk is not zero, and the cost of confusion is high. Ash doesn't have to end a city to damage an economy. Swarms don't have to become an eruption to exhaust a population. A long period of unrest can be its own kind of disaster, because it drags on nerves, drains trust, and turns every normal sound into a question. And that is the real supervolcano fear most people don't say out loud. It's not the Hollywood blast. It's the idea of living with an unseen machine under your feet that might calm down, or might not. So here's the honest landing. The Mediterranean is one of the most geologically active neighborhoods on Earth. That's not a prediction, that's the setting. Etna is active because Etna is built to be active. Campi Flegrei is watched closely because its history and location make every change more serious. Stromboli and Vesuvius sit in the same busy arc of tectonic stress. Marsilli and other underwater systems remind us that not all hazards come with a visible warning sign. And above it all, satellites and space weather monitoring remind us that modern life depends on both the ground and the sky. And sometimes the problems overlap even when they aren't connected by cause. So no, this is not a message that the world is ending. This is a message that we are living on a planet that moves. And the smartest species on that planet is the one that learns to listen without losing its mind. If you take anything from this story, take this. Don't let fear drive you. Let facts guide you. Don't chase the loudest voice. Follow the clearest data. And don't wait for fire to start paying attention. The warning signs, when they matter, show up long before the flames. If you want more updates like this, click the next video on your screen now.